In our last video, we added a scoreboard and sound to our Brickout game. Today, we're going to give the player the ability to shoot brick-destroying lasers from the paddle. Let's get started. My vision for lasers is pretty classic, I think. Little white rectangles emanating from the paddle, moving up toward the bricks, and destroying any bricks they touch, or if they miss all bricks, disappearing off the top of the screen. Because they'll have independent movement and will want to be able to detect collisions between lasers and bricks, I'm going to make them a subclass of Sprite. We'll need to do a few things we haven't done before. Generate the lasers while the game is running, in the game loop, probably as a result of a key press. To make it look like they're coming out of the paddle, we'll need to give them a starting location that is the center top of the paddle. But remember, the paddle moves around. And finally, we'll need to check for collisions between potentially many lasers and many bricks. It might sound complicated, but with your current knowledge and a few additional pygame functions, it will be surprisingly easy. Let's start with a laser sprite. A laser sprite is a little colored rectangle that starts at an XY location and moves straight up. You know everything you need to know to write that, so pause the video and build yourself a laser. How'd you do? I'll bet you have a laser class that looks a lot like mine. First, a subclass of pygame.Sprite. In the init method, I take x and y coordinates as parameters. I also added a few keyword arguments, width, height, color, and speed, so the laser can be customized. If you don't pass them, the defaults are used. If you do, you can override just the ones you care about. Inside init, I invoke the super init method, and then create a surface of size width and height, and fill it with color. Get the rect from the image, and locate it at xy, and set the dy field to the parameter. Now, I'm locating the laser by setting the bottom of the laser to the y value, and the center x of the laser to the x value. So I'm assuming I'm getting an xy coordinate that is the center top of the paddle, and the laser will start its journey from the top of the paddle. I plan to put all of the lasers in a group so they can clear, update, and draw, and so we can check for collisions with the bricks. So I'll need an update method. In update, I add self.dy to self.rect.y. Remember, dy is negative because the top of the screen is 0, so adding a negative value will move the laser up. But what do we do at the top of the screen? We don't want the laser to continue to update if it's out of play. So I'm going to check for when the laser's bottom is above the top of the screen with self.rect.bottom less than or equal to 0. And then I'm going to send the laser the kill message, self.kill. The kill message will remove the sprite from all groups that it belongs to. I'm envisioning the laser as belonging to only one group, the laser group. If it's not in the laser group, it will no longer clear, update, and draw. And because there aren't any other references to the laser, it will get marked for garbage collection by Python, which will clear its space in memory for reuse. Now that we have a laser sprite, we can work on creating lasers that emanate from the paddle. I'm going to write a function to do that, which I will call fireLaser. Let's think about what that function will need to do its job. I'll pass in the keys so the function can check if the fire key is pressed. To create a laser, it's going to need the paddle so it can get the correct location for the laser. And to add the laser to a group, it will need the laser group. In the function, I'll check if the player has pressed the up arrow, which is what I'll use for firing a laser for now. And if it's pressed, I'm going to add a laser to the laser group. So lasergroup.add, laser, paddle.rect.centerx, paddle.rect.top. Remember, again, when I created the laser, I assumed the XY coordinate I got was the top center of the paddle. We're really close now. Before the game loop, I'll create a laser group, and that will start out empty. I'll send it the clear, update, and draw messages, clear with the other group clear messages before anything moves, and update and draw down at the bottom of the game loop. The only thing I need to do is invoke the fireLaser function, which I will do after I get the keys with pygame.key.getPressed. I am sending that list to the paddle so it knows what direction to move, and I'll also send it to my function, along with the paddle and the laser group. And if I run the game, I can press the up arrow, and, well, I can get pretty much continuous lasers by holding that key down. In fact, I can forget all about the ball and just destroy bricks with lasers. The lasers are also all run together if I hold the key down, more like a laser beam. That's too easy, and it doesn't look good. Let's slow that down a little by putting a delay between laser firings. If we're going to add a delay, that means we need to keep track of time in some way, and we can use the pygame.Time module to do that. The time module has a getTicks function, which will return the number of milliseconds since pygame init was called. If we store the ticks when a laser is created, we can calculate the number of ticks when the player tries to fire another laser, and if it's not enough, we can simply not fire the laser. You know I'm a fan of encapsulation. Instead of having variables for the cooldown period and last shot time floating around in the game loop, let's put this functionality into a laser manager class. There will also be a payoff if we want to enhance the laser management in a future version of the game. I will create a class called Laser Manager, and it will have a field for the cooldown period and a field for the last shot time. In the init method, I'll set self.cooldown to 500. That is milliseconds, which is a half a second. If that's too long or too short, all we need to do is change the value. And let's hold off on setting self.lastShotTime for a moment. We'll return to that. We're going to incorporate the fire laser function into the laser manager, but I'm going to call the function update. It will take the same parameters, but we must insert self as the first parameter because this is a method of the laser manager class now. Let's incorporate the cooldown period into this method. I'll get the current number of ticks with now, an int, equals pygame.time.getTicks. Now minus the last shot time will be the number of milliseconds that have elapsed since the last shot. If that is greater than the cooldown period, then that means enough time has elapsed for a shot. So if that's true, then we'll create the laser. We must also then set self._lastShotTime to now, because we just shot the laser, and we'll start our cooldown comparisons from now forward until the next laser shot. So let's think about how we initialize the last shot time field in the constructor. We want to ensure that the first time a laser is fired, the condition now minus self.lastShotTime is greater than or equal to self.cooldown is true, and we can give it a numeric value, for example, pygame.time.getTicks minus self.cooldown. That will work, but I think the clearest way to do this is to initialize self.lastShotTime to none, and check for that in our condition. If self.lastShotTime is none, or then the rest. Short-circuiting will ensure that we don't try to subtract with the value if it's none, because the condition will already be true. And it's very clear that we're checking if there was a last shot time, whereas the mathematical initialization of the field is a little more opaque, but either will work. Down in the asset creation area of the game, we'll create the laser manager, and we'll create an empty laser group, and then where we were previously invoking the manage laser function, instead we can send the update message to the laser manager, again with the same parameters. And now if I run it and hold down the up arrow key, we have a delay on the lasers, so they're distinct and not too powerful. We can adjust the delay if we want them to be even more restricted or less. Now, I talked about enhancing the laser, and frankly, I think it's not fitting well with the game because it doesn't have a sound. I've grabbed a laser sound off of freesound.org that I'll link in the description, and I'm going to pause, add that laser sound in, and come back. You already know how to add sound to the game, so I'm not going to go over that process, but the code is in my GitHub repo, so you can see how I did it if you like. There's a link in the description. Okay, they make sound, but the lasers don't actually do anything to the bricks, so let's fix that. We'll need to check for collisions between the multiple lasers that may have been fired and the multiple bricks that they may have collided with. So far, we've checked for collisions with pygame.Sprite.Sprite collide, which checks for collisions between one sprite and one group. For the lasers, we'll want to use pygame.Sprite.Group collide. This function checks for collisions between two groups. In the game loop, after checking for collisions between the ball and the bricks, and the ball and the paddle, I'll check for collisions between the lasers and the bricks, with hits equals pygame.Sprite.Group collide, and then for the arguments, brick group, laser group, true, true. So that's group 1, group 2, group 1 kill, and group 2 kill. I want both the lasers and the bricks to be removed from their groups if there was a collision. But we don't just want them to disappear, we want to get the points from the bricks and add them to the scoreboard. And we can get at the bricks with the return value from the group collide function. I've stored it in a variable called hits. This is a dictionary with the sprites from the first group that collided as the dictionary keys, and a list of the sprites they collided with from the second group as the dictionary values. So if brick 1 had laser 1 and laser 2 run into it, brick 1 would be a key in the dictionary, and a list containing laser 1 and laser 2 would be the values for that key. This allows for us to process effects of collisions between specific sprites if we need to. All we need to do here, though, is extract the points from each brick that was collided with and add them to the scoreboard. I'm going to write if hits for brick in hits, scoreboard.addPoints, brick.getPoints. We could iterate over both bricks and lasers, both keys and values in the dictionary, but we don't need to for this application. If I run that, I can now destroy bricks with the lasers, and the points are added to the scoreboard. We've covered a lot of ground in this video. We've learned how to create sprites on the fly, sprites that emanate from another sprite. We've learned how to calculate time differentials, and we've learned how to detect collisions between multiple sprites. So let's take a pause while you practice with your new skills by using Group Collide to check for collisions between the ball and the bricks, and the ball and the paddle. Why? So we can add power-ups that give us multiple balls or multiple paddles. Let's lay the groundwork for that. If you get stuck or want to share your successes, please drop a comment below. And as always, have fun and keep coding.